Hello and welcome to the Chemistry Academy. In this video we're going to go over section 1 of the 2025 National 5 chemistry paper. If you're looking for help with any section 2 questions, then you'll find them in separate videos in my National 5 chemistry playlist. So in this video, like I said, we're just doing the multiple choice questions of the 2025 SQA National 5 chemistry paper. So if we get started, the first question is asking which group of the periodic table this element should be in, and it's giving you the electron arrangement of the element. Now, from the electron arrangement of the element, we can work out what group it's in based on the last number in that electron arrangement. So here it's number 8. If you weren't sure off the top of your head which group that would mean it goes into, then you're best to go to the electron arrangements page in the data booklet. And if you scan the page, you should find that anything in group 0, with the exception of helium, has the last number 8 in its electron arrangement, which means that that element, oganesson, would go into group 0 because it has that outer electron arrangement of 8. Question 2, which line in the table shows the correct number of protons and electrons for the atom? And you've been given a nuclide notation here. So just remember the bottom left-hand number is the atomic number. That tells you how many protons. So that helps us rule out A and B because we know there's now 26 protons. So we have to choose between C and D. For the numbers of electrons, this can be worked out from the number of protons and then looking to see if there's any charge. If an atom is overall neutral, it means it's got the same number of positive protons and negative electrons. So because there's no charge up here, it means the protons and electron numbers must be the same. So that means it would be 26 and 26. If you were asked about neutrons in this instance, just as a wee bonus, just remember the top number is the mass number, and that tells you the protons plus the neutrons. So if you're trying to work out a number of neutrons, you really just need to do the top number, take away the bottom number, and that'll give you the numbers of neutrons. So then question 3, which of the following molecules contains 3 atoms? So the best place to start here is by looking at chemical formula. So if you have a look at the first one, phosphorus trichloride, there is a prefix in the name there, so you can use the prefix to work out what the formula is. Because there's no prefix in front of the phosphorus, that means there's only one phosphorus, and then the trichloride means there's 3 chlorines, so that would be PCl3. So we can see that 1 phosphorus plus 3 chlorines would be a total of 4 atoms, so that rules that answer out because we are looking for 3 atoms. For B, magnesium chloride, there's no prefix in there, so we would have to work out the chemical formula using valencies. So if we just do that quickly, we've got the symbols Mg and Cl. Magnesium's valency, it's in group 2, which means its valency is 2. And then chlorine is in group 7, which means that its valency would be 1. Just remember the valency pattern goes 1, 2, 3, 4, 3, 2, 1 and 0. It's a good idea to actually write this in your data booklet for when you're studying. It just helps you when you're preparing for your exam. You can also put the charges of ions based on their group on this page as well. It's a good one to put in. It's basically the same as the valency pattern, except it's got the pluses and the minuses in front. But anyway, back to this question. So we've got our valencies 2 and 1. We swap them over, that's 1 and 2, which means there's 1 magnesium and 2 chlorines or chlorides. Now, that would be 1 magnesium and 2 chlorines is 3 atoms, so that's a potential answer, but we're going to come back to that in a minute. Then we've got C, sodium fluoride. So again, there's no prefixes there, so we need to do our valencies. When you're going through questions, like I've just done here, B, like I've said, is a possibility. Don't just straight away think, oh, that must be the answer. Make sure you check all the other options first, just to be sure, because you will find, as we'll see in this question, that there's usually 2 that are one's very close to potentially being a correct answer, but there's just something not quite right about it. So the valency for sodium, it's in group 1, so its valency will be 1, and we already know that fluorine's also a halogen in group 7, so that would also have a valency of 1. Which means that swapping them obviously is making no difference, so we have Na and F. So if that was a molecule, that would only have 2 atoms, which is not what we're looking for here, so it's definitely not going to be C. if I just note that, and then, sorry, MgCl2. So then the last one, we've got carbon dioxide. Now there's a prefix in that, so we can use the prefix to tell us what the formula is. There's no prefix in the front of the carbon, so then there's just one carbon, and the dioxide means there's two oxygens. Now one carbon and two oxygens. Now one carbon and two oxygens would equate to 3 atoms, so that could be another potential answer, which is why, like I said, don't just go straight to the first answer you think it might be. Now, the little piece of information that's very important here is that you're looking for a molecule. Magnesium chloride is an ionic substance because there's a metal and a non-metal, which means it doesn't form molecules, it forms ionic lattices. So for that reason, it's not going to be B, it is going to be D because it's the covalent molecular substance. Carbon dioxide is a covalent molecule. So a bit of a tricky one here, because if you did just go through the answers and pick the first one that could potentially be right, you might have been caught out here. So then question 4, the bonding and structure that you never find in elements. So if you've got an element, you've got the same type of atom. In an ionic lattice, you need metal atom or metal ions and non-metal ions, which means that you must have two different elements. So you can never get an ionic lattice structure if you just have an element. For question 5, which of the following compounds would conduct electricity at 600 degrees? So this requires your knowledge of the properties of bonding. Just remember that metallic solids and liquids will conduct, and also ionic solutions or liquids. So we can rule out some answers first of all by looking to see which is, if anything's metallic or ionic. Silicon dioxide, that's all non-metals. Silicon and oxygen are non-metals, so that's covalent, so it's not going to conduct. Lithium bromide, that's ionic, so that's a potential. Ammonia, that's a molecule of NH3, which would not conduct electricity because again that's also covalent. And then barium chloride, that's ionic as well, so that's another potential. So the thing that's going to help us decide between these is to decide which one's going to be a liquid at 600 degrees or molten at 600 degrees, because that's when it will conduct, because the ions will be free to move. So there is a page in the data booklet that has some melting and boiling points of some inorganic compounds. So we've got some here. Barium chloride, we can see won't melt until 961 degrees. So our temperature of our experiment's at 600. So at 900 degrees, or at 600 degrees, sorry, barium chloride is going to be a solid still, because it won't melt until you get up to 900. So there's still 361 degrees to go until it will actually melt. So it's not going to conduct. The lithium bromide, it's melted at 550 degrees, so it melted 50 degrees ago. So it will be a liquid, which means that it will be able to conduct. So lithium bromide is our answer. The barium chloride, although it is ionic, would not be able to conduct at 600 degrees because it would still be a solid. So question 6, which of the following oxides when shaken with water would give an alkaline solution? What you need to remember here is that it's the metal oxides that produce alkaline solutions. The way I remember that is that there's the group called the alkali metals. So we're wanting to look for a metal oxide. Non-metal oxides will turn solutions acidic if they dissolve. So if we go through the options, calcium's a metal, nitrogen's a non-metal, so it's not going to be that oxide. Sulfur is also a non-metal, so it's not going to be that oxide. And nickel is a metal, so it could potentially be that oxide. If it's going to change the pH of water, it needs to be soluble in water. It can't change the pH unless it can dissolve. So we need to then check the solubilities table. So if we go to the solubilities table, we have calcium and nickel oxide. So if we have a look for the oxide column, look down. So calcium oxide is soluble, nickel oxide is insoluble. So nickel oxide, because it doesn't dissolve in water, will not change the pH of water ever. The calcium oxide, because it is soluble, will dissolve and will change the pH. It will cause an increase in the concentration of the hydroxide ions, which is what makes it more alkaline. Okay, so our answer is calcium oxide because it's the soluble metal oxide. Question 7, a student made some statements about the effect of adding water to a solution of hydrochloric acid. identify the correct statement. So essentially what's happening here is they're diluting the acid. When you add water to things, you dilute it. For these questions, I like to draw a little pH scale at the side. I think it just helps keep you right when you're going through the statements. So if you just sketch down this wee pH scale, where you got acidic, alkaline, and then neutral in the middle. And then it's always good to add on the ion concentrations. So for an acid, you've got more hydrogen ion concentrations. For the neutral, it's equal concentrations. And for alkaline, you've got more hydroxide ions than hydrogen ions. So if we then go through the statements, so the first one is the rate of the reaction with magnesium will increase. Well, we're diluting the acid, which means we're lowering the concentration. So any reactions will actually decrease in rate because from our rates of reaction knowledge, a lower concentration leads to a slower reaction. So A is not correct. For B, the concentration of hydrogen ions will increase, so that's related to our pH scale. So if we're diluting, we're moving from 0 up towards 7. That means actually we're moving away from the more H plus and becoming more balanced, so actually the hydrogen ion concentration is going to decrease. So that's not our answer either. The acid will be neutralised. You can't neutralise an acid by diluting it, you only make it less acidic, so it's not going to be that one either. However, that might have been one that people were like, that might be right. So if we just go to the last one, just to be sure, the pH will increase. So we're starting at low pH. When we dilute it, it goes up towards 7, which means the pH number will actually go up. So that is definitely our answer. For question 8, a percentage by mass question. So you've got the percent by mass equation at the front of the data booklet on the contents page. So it is this one here. What you need to remember is that the M at the top is the mass, total mass of the element that you're interested in that substance. So in this case it's the mass of nitrogen, but if you look at the formula, there's actually 3 moles of nitrogen in 1 mole of ammonium phosphate. So when you're putting the mass on the top, you need to do 3 times the mass of nitrogen. So it'll be 3 times whatever the mass of nitrogen is, divided by the gram formula mass, which is 149, times by 100. If we have a look at what the GFM, or the relative atomic mass, of nitrogen is, it is 14. So we have 3 times 14 on the top. For multiplying that out, that would give us the 42, so it would be 42 over 149 times by 100. So that gives you answer B. The place people probably most likely went wrong here is that they didn't account for there being 3 moles of nitrogen in 1 mole of the substance. They would have just maybe put 14 on the top, so they might have picked A. So just watch out for that in those percent by mass calculations. For question 9, working out the charge on manganese. So when you're trying to work out the charge on a metal in a compound, you need to look at what's attached to the metal. So in this case it's the dichromate. Because dichromate ends in 8, it means that you might find help on page 8. So if we go to page 8, you should hopefully find that dichromate is here, and we can see that it has a 2 negative charge. So if we write the charge on there, there's the 2 minus, that means that the metal that dichromate's attached to, the manganese, must balance that charge out. So there must be a 2 positive charge on the manganese. Now there is only 1 mole of manganese ions, so that 2 positive charge you need to balance goes completely onto that 1 ion. However, if there was 2 manganese ions, for example, so say the formula was Mn2 Cr2O7, then you would have to split that 2 positive charge between 2 manganese ions, so it means that each of the ions would be 1 positive. Okay, so that's something that you need to bear in mind for those questions as well if you're doing other exams. So then question 10, you're told some information about compound X and asked to use it to work out which of the following compound X could be. So if we start off with it's saturated, so alkanes and cycloalkanes are saturated, alkenes are not, which means propene, which is an alkene, cannot be our answer. Insoluble in water, this is one that's maybe not explored as much at National 5, it's probably more of a higher thing, but alcohols are soluble in water, hydrocarbons are not, so that means it's most likely not going to be B. If you weren't sure on the solubility part of it, the last statement kind of gives you the answer you need anyway. So it has 2 hydrogen atoms for every carbon atom. That means that it's essentially fitting the formula CnH2n. So that is the general formula for alkenes and cycloalkanes. We know that it's not an alkene because we've already done the saturation bit, so it has to be a cycloalkane, so it's got to be C. Propane would fit CnH2n plus 2. Propan-1-ol wouldn't fit that either because the general formula for alcohols is CnH2n plus 1 OH. So yeah, only the cycloalkane fits the CnH2n along with the saturation information. So then question 11 is suggesting deciding what the general formula should be. So for these questions, and you'll sometimes get these in section 2 as well, you want to write down the molecular formula for the example molecules they've given you. So the first one is C3H4, and then we've got C4H, 1, 2, 3, 4, 5, 6, and then we've got C5H, 1, 2, 3, 4, 5, 6, 7, 8. So every general formula will start off with the basis of CnH2n, so it's not very good H. So we'll start off with CnH2n, and then we just adjust from there to suit how many hydrogens we need, and you would add on any extra atoms if there were any extra atoms like oxygen or sulfur or anything. So if we take the first one, always take the number of carbons and times it by 2. So 3 times 2 is 6. So to get to 4, we would have to take away 2 from that. So that suggests our general formula would be CnH2n minus 2. Once we've got that, we then just double check it against all the rest. So 2 times 4 would be 8. If we took away 2, that would give us the 6. 2 times 5 is 10. If we took away the 2, that would give us the 8. So it looks like that's definitely our general formula, CnH2n minus 2. Question 12, which of the following formula masses belongs to a hydrocarbon that does not belong to the same homologous series as the others? So this one is a little bit tricky. You want to kind of guess how many carbons are in the hydrocarbon so that you can then work out how many hydrogens it has. So if it's got a mass of 16, it's likely there's only going to be 1 carbon in there because each carbon weighs 12. So 1 carbon weighing 12, that means there's 4 left over for the hydrogens. Each hydrogen weighs 1, so that means there's 4 hydrogens. So CH4 would be the formula for that one. If it's got mass of 44, there's probably 3 carbons, because 3 times 12 is 36. So that'd be C3. If you've got 36 because of the carbons, that leaves 8 for the hydrogens. So that would be 8 hydrogens then. If we've got 58 carbons, if a mass of 58, we're probably going to have 4 carbons. So 4 times 12 is 48, which would leave us 10 hydrogens. And then for 70, a mass of 70, this is really working my 12 times table here, 6 times 12 is 72, so it's not going to be 6 carbons, it's going to probably be 5, which would be 60. So then that would be C5H10. Now looking at all these, we can see that the first 3 all fit CnH2n plus 2, whereas D is CnH2n, so that's the odd one out. So that's either an alkene or a cycloalkane, whereas the other 3 are all alkanes. So then question 13, naming this compound below. So you should notice first of all that it's got a carboxyl group, that's COOH, which means it's got to be a carboxylic acid, so it's not an alcohol, so that rules out B and D. And then for working out if it's propanoic or butanoic, we just want to look at how many carbons are in it altogether. So there's 1 carbon here and 3 in the long chain, so that's a total of 4, which would make it butanoic acid. Oops. If you forget the prefixes, or even like the names of things, you can actually use this page of the data booklet to help you, because it has some names of all the homologous series you kind of learn about, so it helps you with like structuring names, what name endings should be, and then also for the alkanes there's the first 8 listed in order, so you can count down 1, 2, 3, 4, 5, 6, 7, 8, so on, to work out what prefixes should be for numbers of carbons. So then for this one, we're looking at what the full structural formula is from the shortened structural formula we've been given. So for these ones, what I like to do is number the carbons in the shortened structural formula. It just helps give you sort of guide to compare. So any carbons that are not in a branch, in a bracket, sorry, put a number underneath them. And then when we go down to our examples, we're going to number from the first carbon on the left along just the same sort of way. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So then that gives us like carbon numbers to reference and compare. So the first carbon should have 3 hydrogens on it. So that's the case in all of them, which doesn't really help us rule anything out. Carbon 2 just has 1 hydrogen on it. So if we scan down, we can see that B and D don't match that. They've got 2 hydrogens on it, so it's not going to be B or D. Then carbon 3 has a hydroxyl group on it, so if we scan the 2 that are left, they both have hydroxyls on carbon 3, so they're still both potential answers. And then the fourth carbon should have 3 CH3 groups on it. So if we compare those two, this one has 2 hydrogens on it instead, so it must be answer A. Okay, so C is very similar, it just has those 3 CH3 groups on carbon 5 as opposed to carbon 4, so it's got 1 more carbon in it, this one. So then question 15, which of these alkenes does not form 2 products in a reaction with water? So these questions are all to do with symmetry of the alkene across the double bond. So the best thing to do for these is to draw out the chain, the carbon chain of the alkene, and look at if it's symmetrical or not. So but-1-ene is 4 carbons with a double bond between 1 and 2. And we've got but-2-ene. Then we've got hex-1-ene, 3, 4, 5, 6. And then hex-2-ene, 1, 2, 3, 4, 5, 6. So then once you've drawn your alkene chains, you want to draw a squiggly line between where the double bonds are. And then on each side of that squiggly line, you're basically going to draw circles around all the carbons that are connected. And then that helps your brain clearly see which one is symmetrical or which ones aren't symmetrical. So if your alkene is symmetrical, it will only make one substance in an addition reaction because regardless of which side, in this case the hydroxyl group would go on, it's going to end up as a mirror image. Whereas if the alkene is not symmetrical across the double bond, then you're going to end up getting 2 different products. So don't worry too much about remembering which way around the symmetry goes. You're really, in these ones, you can just look for the odd one out. So if you have a look, the only one that is actually symmetrical is B, whereas all the other ones are asymmetrical. There's different numbers of carbons on each side of the double bond. So the answer is going to be B. But because it's symmetrical, it will only make 1 product because you end up with a mirror image when you add on the hydroxyl group to either side of the double bond. So then for question 16, this isn't one you see very often in National 5. These are very common type questions in higher, although they are a bit more complicated in higher, but I guess it's good that you're being introduced to them now. You might know a bit better for next year. So we've got 5 grams of a fuel being burned and releasing 150 kilojoules of energy. So what you want to do is set up a direct proportion relationship here. And like so we know 5 grams is giving out 150 kilojoules. Then we want to calculate the energy that would be released if you had 60 grams of the fuel. So we're trying to work out an energy and we know we've got 60 grams. So I'm leaving a space here because we need to scale down to 1 gram first. It'd be like if you were trying to work out the cost of 1 apple, if you knew how much 5 apples costed, you would take the cost of the 5 apples and divide it by 5. And then if you're wanting to work out how much it would cost you for 60 apples, you would times by 60. So that's exactly what we're doing here. So we scale down to 1 gram, so we divide by 5, and then you'd multiply up to the 60. So this is what we call direct proportion. It's not really commonly taught in maths nowadays. I don't really know why, but because we use it a lot in science. But anyway, that's a curriculum debate for another day. And then, so that should give you 1,800. So that gives you the answer C. Question 17, which of the following is not involved in metallic bonding? The description of metallic bonding is positive ions surrounded by a sea or a cloud of delocalized electrons. So we definitely know there's positive ions and we definitely know there's delocalized electrons. The electrostatic attraction, that's a bit more of a tricky one, but if you have any positives and negatives attracted to each other, whether it's between oppositely charged ions or the negative electrons and positive nucleus in an atom, we would describe it as an electrostatic attraction, which we do have between the delocalized electrons and the positive ions. So it's going to be B that you don't find in metallic bonding. We don't get any negative ions. Question 18, which of the following could be metal X? So everything's connected to silver. If we have a look at what the voltages are, magnesium is the highest, and that's because it must be the furthest away from the silver. The metal X that we're trying to find is lower than magnesium, which means that it must be closer to silver than magnesium, but it's giving a higher voltage than zinc, which means it must be further away from silver than zinc. So if we have a look at the electrochemical series, we've got magnesium here and zinc here. So the only one that's below magnesium and above zinc is aluminium. So it must be aluminium metal that's been paired to silver. So that'd be A. Question 19, which of the following is not a redox reaction? So these, again, this is quite a new question to National 5 exam. I've not really seen one of these before. You used to get these quite a lot in the old higher exams, but they were much more complicated because they didn't show you any charges, which are vital in answering this question, because for a redox reaction you need to see a change in charge. Essentially, redox reactions are where something loses electrons while something else gains them, so there needs to be a change in the charge of things. So if we have a look down the answers, you can see zinc's charge has changed, so is the hydrogen ions, so that must be most likely a redox reaction. Again, in B, charges have changed. They were neutral before and now they're positive and negative ions. C, they've changed charges as well. The iron's gone from iron 2 to iron 3. But in D, everything's charges stayed the same. All that's happened is that they've changed state. So they've gone from being aqueous ions to forming a solid. So that's actually a precipitation reaction that's happened there, not a redox one. This, like I said, is a question I've not seen in the National 5 chemistry exam before. I feel like with the precipitation reaction in there, it's maybe replaced the identify the precipitation reaction type questions, and it's definitely more challenging, I would say, than those, but maybe that's just because we've not been exposed to them anymore, because exposed to them yet, because like I said, if you know that you're just looking for stuff changing charges, it makes it quite easy to answer. So then question 20, which of the following would be recovered unchanged in the Ostwald process? So it's the catalysts that are recovered unchanged in any reaction, and the catalyst for the Ostwald process is platinum. For the Haber process, just remember it's iron, and if you do forget which way around they are, the alphabet can help you, because H for Haber comes before I for iron in the alphabet, and P for platinum comes after O for Ostwald in the alphabet, which is a really very strange coincidence to me, but I don't think that was planned when they named the reactions and the catalysts, because there's too much time in between the name of the metals and the name of the different processes. But anyway, it's very bizarre. So then question 21, in nuclear equations a proton is represented as, so protons, remember, have a mass of 1, so that rules out C and D. And then in terms of what the bottom number needs to be, because it's the top number that's the mass number, protons have an atomic number of 1, because remember the atomic number is the number of protons. So if you have 1 proton, you essentially have the atomic number 1. So the answer would be A. Question 22, which of the following compounds can be prepared by precipitation? They've kind of almost given you the answer to this in that redox reaction question, but anyway, what you're wanting to look up here is the insolubilities table. They're all sulfates, so the quickest way to do it is to find the table and go down the sulfate column and see which sulfates are insoluble. So we've got barium or lead. So if we go back, there's no lead, but there is barium sulfate. And like I said, they basically gave you that answer in 19, because here they have shown the reaction which produces barium sulfate solid. So then question 23, a student was reading the volume of the liquid in the piece of apparatus. Correct volume that the student should record is, so this is a burette and the numbers are going down the way, so remember that you read the burette down the way you're between 9 and 10, and there's 10 marks to get between 9 and 10, so that means each of these marks is 0.1. So you're always reading from the bottom of the meniscus, so it would be 9.2, because it's 2 marks underneath the 9. So then for the last couple of questions, the average of the concordant titer values is, so when I'm doing any titration calculating an average questions, I always scribble out the burette readings because you don't need them, and they just, too many numbers in the table just makes it a bit confusing, and you should always ignore the first titration as well, so you can score that out. So then we're looking for the concordant results, so those are the ones that are within 0.2 centimeters cubed of each other. So the two that are within 0.2 centimeters cubed of each other are 0.1 and, sorry, not 0.1, are 10.1 and 10.3. So the average of those would be 10.2. So you're just adding them together and dividing by 2. But normally it's quite easy to work out the average of the concordant numbers because it's just right in the middle of the two. So you don't always need a calculator for it. And then last question, which piece of apparatus is the most appropriate to measure and transfer the 10 centimetre cubed of sodium hydroxide solution? So the sodium hydroxide solution is the sample. That's what you're titrating. And we always measure the sample volume using a pipette. That's the most accurate way. The hydrochloric acid, which is in this case is what we would class as the standard solution. It's not actually saying in this question. So because the titration was performed using hydrochloric acid, that's your standard solution. That's what goes in the burette. The conical flask holds the sample, but you wouldn't use the volume measurement on the side of it to measure the volume of the sample. It's not accurate enough. And measuring cylinders, we don't actually really use them for measuring things past like BGE science. I don't know why we get you to use it all the time in BGE science, because I feel like we're just setting you up to believe that it's an acceptable way to measure things, but if you're trying to accurately measure volumes, you need to use pipettes. And if you don't have a pipette of the exact volume you need, then the next best thing is a burette. But yeah, always measure your samples using pipettes. So that's the multiple choice. I wouldn't personally say it's that bad. There's a couple of tricky new questions in there, as I highlighted before, that you've maybe not seen in other papers. But hopefully that helps you work out how you would approach them if they do come up in the future. And yeah, if you find this useful, please give the video a like. Don't forget to subscribe, and I will see you again soon.